Hi everyone, my name is Casey and I am a third year biological science major, and today I'm going to help you with chapter 5.2 number 15. So the question is, when 25 milliliters of 0.50 molar H2SO4 is added to 25 milliliters of 1 molar potassium hydroxide in a coffee cup calorimeter at 23.5 degrees Celsius, the temperature rises to 30.17 degrees Celsius. Step A, write a balanced reaction for this neutralization. And step B, calculate change in H, which is the total standard enthalpy of reaction for this reaction. You can assume that the total volume is the sum of the volumes and that the density reaction and the specific heat capacity are the same for water. Alright, let's start with step A. So this is pretty easy. All you have to do is start with your reactants, which they give you were H2SO4, and they also gave you KOH. And so when those two react, you get K2SO4 and H2O. Now this reaction isn't balanced yet. You have to look at the sum of the atoms and make sure that they're both equal on the reactant side as well as the product side. So when we do this, we need to add a 2 here, and we need to add a 2 here. Alright, now that's our balanced reaction for this neutralization. Let's move on to step B. Calculate standard enthalpy. Now remember, standard enthalpy is just the enthalpy change that occurs when a system has 1 mole of matter that is transformed by a chemical reaction like this one under standard conditions. So in order to do this, we first need to figure out how much volume we're dealing with. So they told us up here that we have 25 milliliters of H2SO4 and we have 25 milliliters of KOH. So 25 plus 25 gives us 50 mils. And again, we can read the directions, and it tells us that the density of this reaction we can assume is the same for water, which again they told us is 1 gram per mil. So if water is 1 gram per mil and we have 50 mils, we can assume that we also have 50 grams of reactant. Alright, moving on. We need the specific heat equation. So that is heat denoted by Q is equal to mass times specific heat times change in temperature. All of these we have, so it's super easy. We know that we have 50 grams. And they told us up here that the specific heat is 4.184. And they also told us the difference in temperature up here. Remember, you should do the final temperature minus the initial temperature. So we're going to do 30.17 degrees Celsius minus 23.5 degrees Celsius. Whip out your calculator, and this will get us 1394.03 joules, or 1.39 kilojoules. And we're not quite done yet. We still have one more step, because this is supposed to be specific to enthalpy. Remember, enthalpy is when 1 mole of matter is transformed. So we need to take into account what the molar enthalpy of H2SO4 is. So again, they told us up here that it's 0.05 moles, so H2SO4 is 0.500 molar. And then they also told us that they used 25 milliliters of it, and 25 milliliters is also equal to 0.025 liters. Multiply those together and we get 0.0125 moles of H2SO4. Alright, so now we have the specific moles that we need, and we know how much energy it is. So we just take the energy, 1.39 kilojoules, divided by the nanomoles. And our change in enthalpy is 111.2 kilojoules per mole. And that's our final answer.